All right, today's date is 3/31/21. We made it to the end of the longest month of the school year. We did it. All right, so today I'm going to teach you proportional and non-proportional graphs. Okay? So today, by the end of the day, you should be able to determine if a graph is proportional based on just by looking at it. Just by looking at it, you should be able to determine if it's proportional or not. If it's proportional or not. All right, so all of the graphs that we've done, they all have something in common. If you look at all the graphs that we have done since the very first time we started graphing, they all have something in common. Actually, two things in common. All of these graphs that we've done in the last 15 days or so, here, this one, these three. What do you see that they have in common? In general, I'm not looking at the numbers, I'm looking at the general graph. What do they have in common? They have actually, yes? What do they have in common?
X and Y?
Yes, they do have X and Y, but I'm talking about the actual, so this is called a coordinate plane. This, the pink line, is called your graph. So the pink line is called your graph. The green is given to you. You didn't create it. I know you did because it's distance learning, but that would be already printed for you. You would come in and create the pink line, or it might look right on your screen. So when I'm talking about the graphs, I'm talking about what you graphed. So what do they all have in common? The graphs that you did. That's why I'm like, don't look at the numbers. We're not looking at the numbers. We're just looking at the graph, the line that you did. What do they all have in common? What does this line, this that has basically no information on it, has no numbers on it, has no story, but it looks very similar to all the graphs that we've done in this class. So, any wild guesses of?
The graph, they all have the graph in common?
Yes. What in particular? They all are graphs, but what makes them similar?
They all have 3 lines?
These 2 lines don't count. Only the middle pink line counts.
They all have the pink line?
Yes. Okay. So, what they have in common makes them proportional. So this graph is proportional because 2 things happen. And these 2 things happen every single graph you've actually drawn from me. Number 1, it's a straight line. They're straight lines. When you connected with the ruler, they all lined up in a perfect straight line. It's at an angle, but they all are straight. And the second thing that all of our graphs have in common, all of our graphs, is that they, quote, start or go through, they start or go through what is called the origin.
What's the origin?
Okay, I'll go over that in a second. Let me just write myself a note. Give me 1 second. Writing myself a little note. Hold on. So the origin is 0, 0. Okay, so when you graphed and you graph 0, 0, that's why when we did this, I called it like the second most important point, because I knew this was going to come along. So 0, 0 is called the origin. 0, 0 is called the origin. And your line has to go either start right there at 0, 0, or it has to go through it. Like if we extend this line, it goes through it. So these two things must happen in order for your graph to be proportional, okay? If one of these are not true, then it's not proportional, okay? Proportional graphs are really special. They're special because they meet these two criteria. They're a straight line and they go through the origin, okay? So, yay, this makes it proportional. If you look back right now on your notes, you will notice they all start at the origin and they're a straight line. There's no dot that's like randomly placed. They all create this beautiful straight line and they all start at 0, 0. No matter what graphs, what the unit rate was, constant proportionality, they all meet these two criteria. They're all a straight line and they go through the origin. No matter what craziness I threw at you, it always was that. Straight line, go through the origin. Okay? So now what I'm going to show you are what we call non-proportional graphs. Non-proportional graphs. All right, so we're going to do some non-proportional graphs. So I'm just going to do a basic graph, coordinate plane. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Just real basic. Just going up by ones and ones, okay? Real basic graph. And these are the points I'm going to graph. These are the points that I'm going to graph. So 0, 2, 1, 3, 2, 4, 3, 5. Okay, so these points I graphed on my coordinate plane. I'm going to take my ruler and draw a straight line if I can. All right. So, what makes this graph that we just drew non-proportional? What made this graph non-proportional is the fact that it doesn't go or start at the origin, right? Right here, this point is not 0, 0. This makes me kind of sad, okay? It is a straight line. It's 100% a straight line, but it misses the origin completely, right? So this graph is what we call non-proportional. So we write that down. Non-proportional because it does not start at the origin. It does not start at the origin. And because it does not start at the origin, it's just non-proportional. No matter what, non-proportional. Okay? So because it does not start at the origin, we call it non-proportional because it does not start at the origin. So basically, you got to tell me, like, what's wrong with it? Oh, what's wrong with it, Miss O'Malley, is that it doesn't start at 0, 0. Oh, and because it doesn't start at 0, 0, we can't write an equation for it. We can't call it proportional. It has failed us tremendously. Just failed us all the way around. All right.
Miss O'Malley, what's that word you wrote on the bottom? Starts with a C.
Origin?
Oh, yeah.
Origin.
And the origin is 0, 0.
Yep. So you see this graph, it's a straight line, 100% a straight line. So it does meet number 1, straight line. But number 2 says, does it start or go through the origin? Totally misses it. Not even close. So it would be non-proportional. Now let's look at another graph that's non-proportional. So again, I'm just going to draw a basic coordinate plane, x, y. I'm going to go up by ones. 1, 2, 3, 4, 5. 1, 2, 3, 4. Real simple. All right. And now I'm going to graph these points. I'm going to graph 0, 0. Hey, that's a good sign. 1, 1. Okay, I like that. 2, 3. 3, 2. 4, 5. These are the points I'm going to graph. So just a simple graph. No story. So let's graph it. 0, 0. Ooh, I like it. 1, 1. 2, 3. 3, 2. 4, 5. All right, well, looks kind of odd. Go with it. Go with it. Take my pen, my ruler. So if I connect first 2 points, and then even here, when I put my ruler down, do you see how the lines are not even on the same line? Like if I were to draw this straight line, I wouldn't be connecting all of my points. My points would be outside of this line. Now here I'm going to change the angle. I'm going to go to steeper angle, connect that. What in the world am I doing now? What? Now, what craziness here? Looks like your grade. We went up on our grades, then we took a nap.
It is proportional.
Huh?
It is proportional.
Why is it proportional?
Because it starts at 0, 0.
And you only needed to start at 0, 0 to be proportional?
Isn't
it supposed to have like a straight line though?
Yep.
It can't be a zigzag.
Right. So you're looking really happy. You're just like, yes, it starts at 0, 0. All right. But then your celebration turns into a sad face because right here, it's not a straight line, right? It goes all over the place. So this is not or non-proportional because it is not a straight line. So as soon as one of those things messes up, as soon as you don't have 0, 0, or you don't have a straight line, you're done. It's not proportional. Some of my students is like, what if it has one and not the other? Nope, it has to have both. If it has, I'll turn it back in a second. If it has a straight line and goes through the origin, looks like this, you're good. It's a proportional relationship. As soon as one of these is false, the whole thing is not proportional. You have to have these 2 statements be true. If these 2 statements are true, you have a proportional relationship. As soon as one thing is not true, the whole thing is just, it's ruined. It's just ruined, kids. Now, I had a question in both my first and second period, the same question. So I didn't go over it as a class until someone asked. So I'm going to go over it with you. What if you have, you know, you created a bunch of dots, right? Like you graphed it and you're just like, Miss Amelia, it doesn't go through 0, 0. Look, it doesn't go through the 0, 0. There's 2 ways to do this. If you're graphing and you don't have 0, 0, that doesn't mean it's not proportional. What you have to do, if your graph looks like that, you take your ruler. It looks like it's pretty straight, right? So you go and you connect them. And you make a longer line, a longer line. Does it go through the origin? Why, yes, it does. But Miss O'Malley, my table didn't have 0, 0. Yeah, they're trying to trick you. They're not going to always give you 0, 0. But it's there. The line did go through it. And you're like, oh. Another one is, again, you have your dots. Right? You have your dots. And you're like, well, they didn't give me 0, 0. Okay, well, connect your dots. Okay, Miss Amelia connected them. Okay, well, now connect it to 0, 0. But they didn't give me 0, 0. You're right. Put it on there. See what happens if you put it on there. Okay, I'm going to put 0, 0 on there. What happened to your line? Oh, yes. It didn't make it straight. You're right. Because 0, 0 wasn't a good match. Oh. So there's 2 ways to do it. Either extend the line to see if it goes through, or put 0, 0 and see if you still have a straight line. This line should have been like that, like the blue line, meaning, and you can totally tell it's not going through the origin, right? So if they don't give you 0, 0 from the table, it doesn't mean that it's not there. They just didn't tell you. You got to figure it out. You got to be like a detective and figure out, well, does 0, 0 belong or not? Sometimes it does belong and sometimes it does not. Okay. All right. We did it. Only in 17 minutes. Yikes.